Okay, so this is the video for the Lesson 6 Day 2 notes that was optional to go over, and I'm just going to kind of go over various parts. For this first part, I'm going to go through the first part here, talk about the various parts of the quadratic function and some of the steps that we always want to talk about, and then I'll go through a couple examples at a time in each subsequent video. I'm not going to make this one long video. So the first thing here is this is our quadratic function, ax squared plus bx plus c. Okay, a is always going to be our coefficient, okay, along with b, that's also a coefficient. And remember, coefficient means that they are numbers in front of the variables, and c is our constant, okay? So we have our three terms, a, b, and c, always will represent, ready, numbers, okay? So, a couple things to do here, okay? M value, a value are positive, these two positives. Basically, M is going to stand for our multiplying, okay? So if we multiply two numbers, okay, and then add value, okay? So if we have a multiply value and an add value that are positive, then we're going to get two positive numbers. If we have a multiply value and an add value of negative, then we're going to get two negatives, and so on. It goes through a bunch of those things, okay? So what does this all mean? Well, you still have to go through our steps. We still have to check for our GCF, our greatest common factor, okay? Then we're going to multiply our coefficient of our x squared, okay, which is basically our a value, with the coefficient, or with our constant, okay, and our constant is basically our c. So we multiply a times c. This will give us our multiplied value, okay, m value is what we're referring to it in this case, our m value. Then we're going to factor, we're going to add the factors from step 2 to find our x coefficient, or our b value, okay? This will be our add value, so our a value, okay? And then we are going to try to reduce if possible. And then we're going to kind of solve it, give our answers. We'll go through those all steps. So, is examples. So I'm going to use these first two examples, example 1 and example 4. I'm going to zoom in here a little bit to these various problems. So in example 1, I have 1m squared minus 8m minus 5. Remember, step 1, is there a greatest common factor between 4, 8, and 5? Outside of 1, there's not really. So then we're going to identify our a, our b, and our c. And we're going to use the factor x's. We're going to take our a value, multiply it by c. So 4 times negative 5 is negative 20. And then we're going to take our b value, negative 8, and bring it down here. What we're going to do next is we're going to look for our multiplying value. What two numbers multiply to the negative 20 but have to add up to our negative 8. So there's our m value, negative 20, and add value, negative 8. So just like we talked about above, since I have a multiplying value and an adding value that are both negative, then I should have two negative numbers inside my factor x. So I got to think of two different numbers that can multiply to negative 20 but add up to negative 8. And as I say that, it can't be two negative numbers, so I wrote that up there wrong. Because if I get a negative here and an added here, okay, to get a negative number, that means I have to have one positive and one negative. So what numbers can multiply negative 20 but add up to 8? Well, I can think of a couple ideas. We have 5 and 4 multiply to 20, 10 and 2 multiply to 20, 20 and 1. But which of these set of numbers could give us a number 8? Well, this looks like 9, that looks like 18 or 19 or 21. So I'm going to look at the 10 and the 2. So now the question is, which one's negative, which one positive? The best way I always explain this one is, well, if this is a negative, then it should be negative 10 here. And if this is a positive, then this should be a positive there. So here are my two factors, negative 10 and 2. What we're going to do now is we're going to take these factors, we're going to go back to our original three terms. We're going to take negative 8m, and we are going to break it up to the two parts that we found, negative 10m and positive 2m. First term does not change. Second term does not change. Or last term does not change. Now I have 4m squared minus 10m plus 2m minus 5. I have four terms. I'm going to group these terms. Greatest common factor between 4m minus 10m. So both are divisible by 2, and they both share an m. So I factor out a 2m. 4 divided by 2 is 2. M squared divided by m is m. Negative 10 divided by 2 is negative 5, and the m's cancel. I do the same thing here. positive 2m minus 5. Well, the greatest common factor, there has to be one, and it's got to be a positive 1 because nothing else goes in there. Well, if I take it out of positive 1, nothing changed inside my parentheses. So I should have, at this point, two completely the same parentheses. I do. They're going to come in front, 2m minus 5. And then what's left, that's outside, another 2m, but then plus 1. And these are our two binomials. This is example 1. Now if we go over to example 2, okay, we got to start with the same process. Is there a GCF between 2, 12, and 16? And the answer is yes. Actually, there is a GCFS. I can divide all these terms by 2. So we have to do that first. So we're going to divide every single term by 2. 2 comes out front. You're left with a squared. Negative 12 divided by 2 is negative 6a. 16 divided by 2 is 8. Now, we're not quite done yet because we have to ask ourselves still, okay, we've done GCFS. Do I have 2 terms, 3 terms, or 4 terms? And the answer is I still have 3 terms in the parentheses. A squared minus 6a plus 8. I still need to find the a, the b, the c. A is 1, b is negative 6, and the c is 8. So I have to ask myself, can I actually break down what's inside these parentheses? Well, the only way to find that out is to do the factor tree. A times c, 8, is supposed to add up to negative 6. So are there any two numbers that can multiply to 8 but add up to negative 6? Well, to multiply to a positive 8 must mean that I have either 2 positives or 2 negatives. Well, to get a negative in my add value, they must mean there are 2 negative numbers. So negative 8, I got to think about what 2 numbers can multiply to 8. I'm going to think of 4 and 2. Negative 4 and negative 2 add up to 6, negative 6, and the answer is yes. So what am I going to do now? I know this actually factors. Well, the 2 out here still stays 2. That's not changing. What I have to look at inside this parenthesis is, well, the a value inside the parenthesis is 1. So we know that if the a value is 1, I can just immediately go to my 2 parentheses, a, and I can then put my terms minus 4 and minus 2, and this is our fully factored